Hi guys, welcome to Learn Electronics Repair. This is where I fix stuff and hopefully teach you how to do it as well. This is a MAG box in for me. These are TV streaming boxes and we see quite a lot of them over here because we have people of all nationalities living over in Maspalomas, Gran Canaria, because it's a nice place basically. So one of the common things you find with these, and this applies to Android boxes as well, so not just the MAG boxes, but I've had the same problem with Android boxes. This one's a 12 volt supply. Quite often the Android ones are 5 volt and some of the MAG boxes are also 5 volt. And what tends to happen is people plug the wrong power supply in. Now it's probably fairly obvious if you plug a 12 volt power supply into a 5 volt box, then it will cause the box to fail. What might not be quite so obvious is if you plug a 5 volt power supply into a 12 volt box, it can actually do the same thing, and it's not unusual to. So I'll show you what's wrong with this one. I'm pretty sure I can find the fault on it. I've seen these problems before, and I'll also explain why a 5 volt power supply will cause a 12 volt box to blow up. So we can take the lid off and you can see the power's coming in here. Now if I just get my multimeter, and there it is, so you can see it, we'll check the power supply. So this is a 12 volt power supply, it's the correct one for the box. We'll just check it, and we have 12 volts, close enough. Okay, so we plug this into our box. You can see that the 12 volt comes in here, so this is the 12 volt and this is the ground. And look what's happening. You see, the power supply is repeatedly trying to start and shutting down again. And there's two main reasons for that. Either the power supply itself is faulty, quite often capacitors in the power supply have dried up or bulged. The power supply may not be able to deliver power under load, so it will do that. The other common reason, and really the only other reason, is if the load is too low resistance. So let's go on to the ohms range and let's have a look. So we'll measure from the ground to the power coming in, and you can see it's reading 16 ohms. That's too low. You'd expect it to be possibly into the kilo ohms. That's too low. So that indicates there's a short on the unit. The question is, where is it? Well, let's have a look. If we look at the power supply section of this TV box, streaming box, you can see this is the 12 volts coming in, and we know effectively from here is a low resistance to ground. It's not a short, but it's a low resistance. And then you can see 1, 2, 3, 4 coils, inductor coils. Each one of these is a power supply, and in fact on this they've actually marked quite nicely for us. So this one says 1.5 volts DDR, that will be powering the memory. We have a 3 volts supply, 3.3 volts, it says D 3.3 volts. We have another 3.3 volts saying A 3.3 volts. The chances are one of these is a standby power supply, another one is the main 3.3. We have a 5 volts, and we have 0.95 volts pointing to this coil and pointing to the heatsink. This is the processor chip. So this coil is driving the processor, this one is driving the memory, this one is driving 3.3 volts, and it looks like either, yep, this one's pointing this way, 3.3 volts, and we have 5 volts, and we also have 1 volt. So that's all the supply voltage on here. The coils will be driven by controller ICs that send high frequency pulses into the coil to generate the low voltage output. And you can see there's a thick PCB trace going to this one and this one from this chip. So this chip is responsible for these two supply voltages. There's another chip here, little 6-pin chip, and you can see there's a track which goes under here. So that will be responsible for driving this coil, which looks like it is 3.3 volts. We have the one here, which is probably driven by that one. I need to find out. We can measure it in a minute. And we have another chip here. So this one is probably just a 5-volt supply, which will be a low current supply. So it's just a linear voltage regulator, not driving a coil. That's probably what we have. But we can work it out. I mean, this one we can clearly see where they go to. So if we go on to resistance mode, we go from one of these coils, it'll go to this chip. We can see where it's going. There, yeah. And this coil is also going to here. Okay. This coil, is it going to this chip? Is that like? Yeah, it looks like it goes to that one. Oh, I'm seeing the short, the low resistance there. Okay. So it doesn't go to that one. Does it go to this one? I need to find a 0. Doesn't go to there. Is it also going to here? Yeah, there. So that coil and these ones are all driven from this chip. In fact, now you can probably see the thick track. So this controller drives all 3 voltages here, which then leads us to this one, okay? And this one, I'm pretty sure we can see goes to this chip. Yeah, 0 volts. That goes to there. The 12-volt supply will go to all of these chips. This one, and probably at least one of these two. Let's have a look, see where the 12 volts is going to. So 12 volts coming in, goes to this chip. Okay. Does it go to this one? No, that is just the short we're seeing. I thought it would have gone to this in actual fact. No, it looks like that just has ground on it, doesn't have the 12 volts on. And I'm guessing it probably goes to this chip as well. There. So certainly this chip and this chip are powered by the 12 volts. What else is? That one probably isn't, by the looks of it. What about this one? No, that's the ground pin. Okay, so I don't see it there either. So whatever's causing the short circuit is probably this chip or this chip. We can probably find this out a couple of ways. So we could just unsolder this chip and see if it is the problem. If it's not, it's probably that one. Or we could use the thermal camera. There's also a capacitor here as well. That's also on, it has that low resistance across it. That's also going from 12 volts. In fact, it says here 12 volts to ground. Seeing as a lot of you guys don't have the thermal camera, I could use it, but it's not exactly cheating. But I'm going to try and do this if I didn't have one, okay? So what I will do first is to stick some voltage into here off my bench power supply and see if either this chip or this one is getting warm. I have my power supply connected. I actually have 12 volts on here, so it's fine. The power supply, I'm going to turn the current down up a little bit just so it's actually, yeah, it's on now. Yeah, you see the little green light came on. So as soon as I plug this into the box, the red light is going to come on and it's drawing some current. Yeah, so we'll just take the current up to about 800 milliamps will do. And I want to see if I can feel something getting warm in here. Okay, that's not enough to actually warm anything up that I can feel it. Let me go a little bit more. So we have about 1.5 amps now. Is anything getting warm? Yeah, this chip here is getting warm. That one, which is the one I thought it was most likely to be. I'll use the thermal camera, I can show you that. So I know where the problem is. I was using the finger test, but you can't see that as such, so I'll switch the power supply on now and you should see this get hot. Yeah, you see it there? It actually looks like it may be the capacitor. So down here is a capacitor and a chip. Let me see if I can see which one it is that's actually getting hot. Okay. Well, the capacitor is actually here, and that looks like the actual thing that is getting hot. Here's the capacitor. In fact, you'll see there's another one next to it as well. And this has the 12 volts across it. I could actually measure the low resistance across it before. Let's have another look. Well, it now actually reads short. So it looks like sending 1.5 amps through here has actually caused it to go completely short. There's another capacitor next to it. Okay, reading short. And if we read from ground to this chip, we'll also find the short on that pin, okay? And that's because the 12 volts goes to all these components. It felt like this was getting hot, but it could be this one. The easiest way now is probably just to remove the capacitor or capacitors. If it isn't one of these, it'll be the chip. I don't think this capacitor's on the 5 volts or ground. No, so that won't be involved. And this is getting further away from where the problem was. Although we still see the short here, this is getting further away. The problem was over this side. Let's remove these components, or we'll do the big one first because it's easier to get to that one and then get to this one afterwards. And let's see where the short is. I've removed the capacitor. I did it on video only to find I forgot to hit record after my face camera froze. But this is very simple to do. So this is the actual capacitor itself. Okay, and all I did is I added a bit of leaded solder to both ends of it, and then I came in with my soldering iron with the BC3 tip. To do this, you want a soldering iron that's wide enough to go across the whole capacitor. I came in from the side, the capacitor stuck to the soldering iron, and I was using the tweezers in my other hand, and I just pulled the capacitor off the soldering iron. So that's the capacitor desoldered, but if that's faulty or if it just needs refitting, I will show you the next time, and I'll remember to hit record. Okay, so there's the capacitor. Let's have a look to see if the short is still on our board. Okay, so ground and the capacitor. Well, one end is ground anyway, and the other end isn't. That's 12 volts. In fact, we can go to the 12 volts on the connector. So the short has gone. So the short must be now a capacitor. Now sometimes when you desolder them, the short disappears. Well, let's have a look. Ah, I heard it. And there you are, guys. The capacitor is short. So we can replace this. It's not critical. It needs to be something that's more than 12 volts. I'll probably put a 10 microfarad 25 volt in there, but to be quite honest, this will work without it. It's just there to give a little bit of extra smoothing or decoupling where the power comes in. Normally this one's around 10 microfarads and this one will be about 100 nanofarads. Those are typical values. If you find something like this, that's what you would replace them with. Here is a capacitor. So this one is a 10 microfarad 0805. That's the size. SMD capacitor. It's smaller than this one. Now that may well mean it's a lower voltage. I'm pretty sure these are 25 volt capacitors in the 10 microfarads, but if I can find a slightly larger one that fits, it will be a higher voltage capacitor as well. So let me try the next size I have up, which is 1206. These are 1206. These are slightly bigger than the original, but I'm pretty sure I can get that to fit on there. So I'll actually use one of these. But I'm fairly sure the other one would work okay. Anyway, I think it's a high enough voltage. Okay. Will it fit? Is it too big? No, I'm fairly confident I can get that to go on there, to be quite honest. The solder traces are wide enough. Unlike electrolytic capacitors, these are not polarized. You can put them either way you wish. I'll put a little bit of solder on the pads and then let's see if we can solder this down. This is a little bit more fiddly because the pads are basically the same width as the capacitor. I'll put a bit of solder on each side. I could use hot air, but because I have the socket right next to it, I'd rather not do. If I can avoid it, I may end up actually fitting the smaller capacitor. It'll be easier to fit. But let's see if we can get this to solder down. So the way I'll do this, you see I've put some leaded solder on both pads. I'm now going to clean it off one of them. Okay. So I just have a bit of leaded solder on one pad. I should now be able to slide the capacitor into that solder. Okay. So we'll get this on the board. I'll melt that other solder and it should just effectively slide into place. Let's try it. Okay, that's one end down, and then hopefully I should get enough solder this side just to go underneath it. We can try. This might be the fiddly bit. I'll add a bit of flux, it will help. Okay, we'll soon know if it's connected because we can measure from the capacitor. Bit of solder. And then I'm going to hold the capacitor down so it doesn't move while I'm doing this. Okay. I'll actually use this soldering aid. It's probably a bit easier than using the tweezers. I get a bit of pressure on it. And that should have soldered. We can test it. We can check. So this end is soldered, and from 12 volts, yeah, that's soldered. I can just clean that up with a little bit of isopropyl, and then let's try it. We can see then on our board we don't have any short anymore. Okay, ground, 12 volts. Let's power it up and see if it works now. There's a little LED on the front, so it should light up. Yeah, LED's on. So it's now running. It's actually drawing, I can tell you, about 250 milliamps. And we can just check around this now out of interest. So we have on this coil 5 volts, okay. 0.9 of a volt, this was 1.5, and this was a 3.3. Yeah, so all those voltages are there. I'll connect it up onto the TV, we can just see if it's working, but I'll just mention a few other things about these that you may come across if you're repairing these sort of things in Android boxes. It's very common if the wrong voltage power supply is being attached for this chip to fail, or one of these chips, okay. And if you look at it, it's just marked with 200. Just wiped off a little bit, you might see it a bit better. Yeah, you can probably see it now, the number is 200. These are quite common. You can buy them on AliExpress. And there's two main versions of them. So the one that's marked 200 is this chip, and I'll actually put this number on the screen as well. TPS 563-200 DDCR. You can get a whole pack of them, 10 of them for €1 or €2. And you often find a similar one, which is this one. Yeah, 562200 DDR. So you have 200 and you have 2200. Okay, 3200 2200, and this one will be marked 200 on the chip, as is mine, and this one will be marked 300 on the chip. The difference being that this one is a slightly higher current. Yeah, this one can handle a bit more current. They're pin for pin compatible. You may even be able to use the higher current one, but I keep them both in, and I find quite a lot of these, and they're quite often faulty. I'll attach the HDMI. We'll see if this works on my capture card, so you can see it on screen in a minute where those colour bars are. Just plug it in. So the white light's on. Will it work with the capture card? No. I will just do a master reset on this. I'll actually show you how to reset one of these if you need to. So there's a little button on the back which you hold in, you plug it in, and then if you watch the light on the front, it'll flash slowly about 6 times, and that'll flash rapidly. Okay, hold it in for a few seconds and then let go, and that will reset the box, and it should now boot up to a clean operating system. It will do this several times on and off like this. It's normal, part of the boot sequence. Okay, just wait a little while and it should come on. The colour bars you see are actually coming from my HDMI capture card, not from the mag box, and there we have it. So this is now in the factory default condition. Okay to confirm. And we have the menu. So that one's fixed, guys. Quite a simple repair that. If you're looking at these, bear in mind it's often the little chip there, you know the type of chip it is now, or the capacitor. Usually this one doesn't go short. In my experience, I've never seen that one fail actually, maybe once. So this is the sort of repair I can do. Charge the customer €45. At the moment there's a shortage of mag boxes, even used ones will cost you €90 to 100. So it's definitely worth repairing, a little bit of work, nice little profit for me, and a nice saving for the customer. Hope you enjoyed that, guys, and I'll see you all soon on another Learning Electronics Repair video. Ciao for now, guys.